Hello grade 9 students. We're gonna solve some exercises about AC voltage. As a first exercise, which is extracted from the official exams of grade 9, we have a voltmeter and an oscilloscope connected across the terminals of a generator G delivering an alternating sinusoidal voltage U as you can see in the figure. Document 2 represents the waveform of U. In the absence of any voltage, the horizontal luminous line passes through the center of the screen. The adjustments are given: vertical sensitivity and the horizontal sensitivity. Before we move to the questions, I would like you to notice this sentence here. In absence of any voltage, the horizontal luminous line passes through the center of the screen. This is the center here. And this sentence is simply setting a reference with respect to which we're going to read our values. So passing to questions, the voltmeter measures the voltage capital U. What does U represent? Then, by referring to document 2, which is the second figure, calculate the period T, deduce the frequency, show that the maximum voltage is 12 volts, and then deduce U. A lamp marked 12 volts is connected across G. L does not glow normally. Why? Justify. Now, before we start solving, I strongly advise you that you pause the video here, try to solve the exercise on your own, then check or compare your work to ours. Part 1, the voltmeter measures a voltage U. What does U represent? We know that a voltmeter in AC mode, so let me just write that, a voltmeter in AC mode simply displays or reads or registers the effective value. The effective value. It can be effective value or you can simply say effective voltage. So capital U is the effective voltage. Okay? Effective voltage. Then, part 2, 2.1, by referring to the document which we have just cropped and added here, calculate the period T of U. Now, to calculate period, and we are given an indication that we have to use the graph, it is trivial. T period equals X multiplied by SH. SH being the horizontal sensitivity. We don't need to explain what does each term stand for because it's given. So horizontal sensitivity is given in milliseconds per division, and thus X is in divisions, and consequently period is in milliseconds. Period can be expressed either in milliseconds or seconds unless it is specified that we have to write our answer in SI units. Then it should be in seconds. Equals calculating X or reading X on the graph. This is usually a common problem. We can either choose from crest to crest and we count. Crest happens to be here, and if we count it, 1, or if we count the X, 2, 3, 4, 5, and 6. Apparently we have 6 divisions over here. I think there are 5. Let me count them again. I'll erase and count again. And I'll tell you later why did I have this intuition that it should be 5, not 6. So 1, 2, 3, 4, and 5. Yes, that's it. So X equals to 5. Now, how did I know that I might have a mistake? I looked at the 0. If you remember, to count X, we can go from 0 to 0, skipping a 0. So this is 1, 0. This is the second. We skip it, and this is what we need to consider. Counting divisions, 1, 2, 3, 4, 5. Pay attention. The division is the box and not the dash. So we don't count the starting dash. Anyway, we have here 5 divisions. Multiplied by SH is given to be 10. I always add the unit millisecond to indicate that it's milliseconds and not seconds, equals 50 milliseconds. I change color because some of you might continue to divide by 1,000 and get an answer of T equals 0.05 second. This is accepted for sure, but this answer is also correct. Why? Simply the question doesn't specify what unit we should use. Now passing to part 2, deduce the frequency. We all know that frequency in hertz is 1 over period in seconds. Here we must convert period to seconds. So if you have kept it as milliseconds, please change it to seconds here. So equals 1 over 0.05, frequency equals to 20. Don't forget the unit, hertz. An important note here I would like to add, don't forget adding units, and with frequency here, you should always have period in seconds. Equals 50 milliseconds, for example, directly convert to become 0.05 seconds. It's obligatory. Moving on to the following parts. 2.3 show that the maximum voltage is U max equals 12 volts. We can either use an equation or simply look at the graph, since the graph is given and the vertical sensitivity as well. So the answer for 2.3 is U max in volt equals Y max in divisions multiplied by the vertical sensitivity SV in volt per division. Now counting Y, we start from the axis because they have set the 0 here. And we count 1, 2, you know what? It's given 2.4. So I don't need to worry about it. 2.4 multiplied by sensitivity is 5 equals 12 volt for U max. Okay, that's it. Don't forget units. When you write units here, we either, let me write this with a different color, we either write the units with the equation, or we can write them here, or in fact, we can say 2.4 divisions multiplied by 5 volt per division. Show that units cancel out and continue. Okay, I'll erase this, or you know what, let's keep it, because some of you might have done it. Now, part 4. Deduce U. They didn't specify what U is, but we already said that U is effective voltage. And we know that U effective for alternating sinusoidal, is given by which equation? Is given by 2 points. U effective equals U max over radical 2. Here I always emphasize on the fact of you should write that this is specifically for alternating sinusoidal. Then capital U equals 12 over radical 2, which equals approximately 8.5. Now, if you are using a calculator, when you read this value, it might be 8.5, 8.4, or 8.6. Don't worry about it. Just round it to one decimal digit. It's more than enough. And I don't recall well if radical 2 is given to be 1.4. You can write it on the calculator directly, 12 divided by 1.4 and not by radical 2. Anyway, the answer is around 8.5, and this is absolutely acceptable. Part 3. A lamp marked with 12 volts is connected to this generator. It does not glow normally. Why? Simply, we know that in AC mode, an appliance or the lamp functions, new line, according to what? According to effective value, to effective voltage, in fact. Let's specify it. And here, U effective equals 8.5 volts is less than U rated, the rated voltage of the lamp. Therefore, the lamp shines or glows dimly or with dim light. Okay, so this was one of the applications. If you have solved it correctly, then excellent. No need to continue for further exercises. And if you'd like to solve more, let's go to solve another exercise.